This is CHEM 2211, preparation of diphenylacetylene. The first step of our reaction will be the dibromination of trans stilbene. We've weighed out 2 grams of our trans stilbene already. We're going to combine that with 40 milliliters of our glacial acetic acid. It's under the hood here because of how pungent the smell is. So we want to make sure we protect ourselves from that. We'll combine them in our 125 Erlenmeyer flask using this powder funnel, and then we'll gently heat it on our hot plate. So we'll go ahead and do that first. Using the powder funnel makes it a lot easier for us to get our solid into the flask without making a mess. And we've got a little bit of solid remaining in the funnel, so I'm going to use the funnel to rinse down. We'll use our glacial acetic acid to rinse down any residue. And we're good to go. And even with the snorkel in place, I can smell that acetic acid. So we'll make sure we keep that underneath. Reposition it over our flask as it slowly starts to heat. And once we get that fully dissolved, we'll add in our next component. We've been dissolving our solid for roughly 10 to 15 minutes between 85 and 90 degrees on this hot plate. Everything's gone into solution now. Our trans stilbene is in our glacial acetic acid. We've weighed out 4 grams of our pyridinium hydrobromide perbromide. This is going to be our Br2 substitute. We're going to go ahead and add that into the reaction flask now. There we go. Make sure we get everything in there. We go ahead and bring the snorkel back down a bit. And I'm going to use a small amount of glacial acetic acid to rinse in the remaining solid in our funnel. And we'll let this react for around 5 minutes or so. I'm going to swirl my contents to make sure we're mixed. And we'll let that react for about 5 minutes, and we'll be right back. We've been reacting for about 5 minutes. And as you can see, we've got some fine yellow solid that's formed in the bottom of the beaker. We're going to take this off the heat now and set it into an ice bath to complete the precipitation of our product for step 1. We'll let it rest in the ice bath for a couple of minutes. We're going to go ahead and move our snorkel over just to make sure we don't have any acetic acid coming out. We'll let this rest for a couple of minutes to complete the precipitation, then we'll go on to the suction filtration phase. So this is our data sheet up until this point. We've got all of our weights that we've weighed out. We did those off camera and filled it in on the sheet for you. And then we've made a few observations at the base of the page. So we'll do a data sheet update as we progress through the experiment. While we're waiting for our precipitation, we just wanted to give you a look at what the data was so far. So we've finished our precipitation. We've got a lot of nice crystal in our flask here. We're going to set up our suction filtration apparatus. We've got our Buechner funnel. We've clamped our filter flask. We've got our hose attached to our vacuum line. We'll go ahead and set the Buechner funnel in place using the proper sized filter paper. I don't know if you can see. We'll move the snorkel here. And I'm going to wet this filter paper down just a little bit with some methanol. And that'll help make sure that we don't lose any of our crystals underneath when we start our vacuum. So I'll start pulling our vacuum here, and we'll gently pour our crystals into the funnel. What looked like yellow crystals now turns out to actually be white after a lot of our impurities have flowed through the filter flask. I'm going to pour 10 mils of methanol into our original flask and swirl it around. That gets any remaining product, and it's also going to help us rinse what's already in the funnel. We want to try and get rid of all that yellow color if at all possible. And we've still got a little bit in the center there, so I'm going to use a couple more mils, let me measure it out here, of methanol to rinse it one last time. So this is going to be roughly 13 milliliters total. We're going to put that on our data sheet. Swirl it one more time. And we'll pour it right through the center. We're going to let air pull through this for about 5 to 10 minutes to make sure that it's nice and dry. Alright, we finished pulling air through our solid, so we're nice and dry. We're going to take it off the Butyl funnel, scrape it off of our filter paper onto our watch glass, and we'll get our final weight of product for our first step. So the first thing that we want to do is we want to make sure that we break our seal at the funnel or at the filter flask. Then we'll go ahead and turn off our vacuum line. I'm going to take my Butyl funnel out, and you may want to come around on this side because I'll have to use my right hand. And then I'm just going to gently start scraping our product. So we've got this nice fine crystalline solid, and we've got an awful lot of it. And we'll scrape the majority of it out first, then we'll take our filter paper off and scrape it a little bit more just to try and get every last little bit from our first step. Now notice as I'm doing this, it may pick up against the black backdrop here, that I am getting some crystals onto the table here. That's not intentional, but that is also a source of experimental error, so that's something that you want to make note of in your lab write-up. I'll get the rest of this out of my Butyl funnel, and then we'll take it over to weigh it. We've set our crystals aside to dry for the moment. We'll give it about 10 minutes, and in the meantime we're going to go ahead and deal with the waste from this step of the reaction. Our orange filtrate that we have in the bottom of our filter flask, we're going to add some water into our solution. See it turning cloudy. We've got our snorkel just above. So we still have a lot of acetic acid. It's still quite pungent. We're going to swirl this around. And essentially what we need to do is add sodium bisulfite, which is what we see right here, to take the orange color out of this filtrate. Once we do that, then we can dispose of it. You can see that it turned nice and white fairly quickly. About 2 scoops, maybe half a gram of sodium bisulfite, and we're ready to go. We neutralized our filtrate, turned it a nice clear white against a white background. Can we see that?
Yeah.
Okay. And we're going to go ahead and pour it into our waste container, and we'll be finished with step 1. We've let our crystals dry for roughly 10 minutes on the desktop. So we're going to take them and weigh them and see what our final weight of our product is for step 1 of our diphenylacetylene reaction. So this is our dibrominated product. I'll go ahead and put this back on top just so that we get a very precise weight. Our watch glass alone, 47.453, plus our product is 50.794. That's our data sheet so far. I'm going to go ahead and find out what our total weight is. .341 grams of our stilbene dibromide. We're going to begin step 2. First step is to take 1.5 grams of our potassium hydroxide, which we've already measured out. We're going to go ahead and put that into our 100 ml round bottom flask. Carefully scrape those all off of our paper. Down into our flask. Our heating mantle is starting to warm up. We're going to add in 20 milliliters of ethylene glycol. Pour that in as well. We're going to gently heat this solution until all of our potassium hydroxide has dissolved. Then we'll move on to adding the next component. So our KOH is fully dissolved in our ethylene glycol in the round bottom flask. We're going to go ahead and put in all of our product from step 1, which is our stilbene dibromide. Once we do that, we'll put in a few boiling chips, set up our reflux apparatus, and let it go for 20 minutes. Try to make sure we get everything into the flask that we can. These crystals are very fine, very small. They tend to stick to surfaces. I'm going to rinse with just a small amount of ethylene glycol. Okay, so I'm going to use a little bit of ethylene glycol, not much. We don't want to dramatically alter the volume of our system. I'm just going to rinse some of these crystals down into the reaction flask just to make sure that we've got everything in there. I think that'll be enough. So let's go ahead and add our boiling chips. and then we'll set up our reflux apparatus. We've got some medium-sized stones here, so I'll add 2 of those. I'm going to take this off just briefly and swirl the contents. And I'll put it back onto our flask here. So our reflux condenser in place. Pull down our clamp so that everything's secure. And then we'll set up our water hoses. Our inlet, of course, is at the bottom. Now we'll go to the end of our water faucet here. And our outlet will be at the top. Oops, sorry. And that goes into the sink. Turn it on gently. And then we'll check our outflow here. That's pretty fast. I'm going to turn it down just a touch. And that's probably a good flow for us for this reaction. All right, our reflux apparatus is set up and running. We'll let that go for 20 minutes and then check on our product. Our reflux finished, and we took our warm liquid and poured it into a 250 ml Erlenmeyer flask, and we've set it on the bench top so that it can cool to room temperature. It is not quite room temperature, it's still a little bit warm to the touch, but it's cool enough that we can go ahead and put it into our ice bath. I don't know if you can see, let me raise it up a little bit. We can see some particulate that's forming in our solution. This was a clear yellow liquid, and now it is slightly opaque, or actually it's quite opaque as the crystals begin to form. When we put this into our ice bath, they should form even more rapidly, and that will give us our impure product, impure final product as a result. See the crystals along the edge here. Okay, we'll wait for that to precipitate and we'll come back. So we've allowed our crystals to precipitate in our ice water bath. We've taken our Erlenmeyer flask out and we can see quite a good bit of solid in our solution. Some of it up on the sides of the flask. We're going to go ahead and filter this. This is our impure product. Filter it using our Buechner funnel, our suction filtration setup, very similar to what we used before. I'm going to wet down the paper, the filter paper for our Buechner funnel with a little bit of water. That's what we're going to be using to filter this and to rinse it. I'll go ahead and hit the vacuum so we get some good suction. Swirl my flask and then filter. Now this can be a slow filtration step, you just have to be patient, but as you can see it's still coming down through the bottom here. Once that's drained, we'll use some of our ice cold water to rinse out the filter flask, to rinse out our 250 ml Erlenmeyer flask, and rinse our impure product that's on the Buechner funnel. So our water has drained off from our Buechner funnel. We can see our impure product. We see some white crystals. We see some areas of light yellow and darker yellow. Now we're going to take our flask, our original flask. We're going to pour about 10 mils of ice cold water into the flask and rinse that into and through our impure product on the Buechner funnel, just to try and remove as many impurities, any soluble impurities that we can. And we'll see that there are some crystals that are stuck to the inside of the beaker. I'll try and scrape as much of that down as I can. Again, this is one of those areas where you want to make mention in your lab report that we may have lost some product or may have left some product in the beaker as we transferred into the Buechner funnel. But we'll try and get as much as we can. Okay, now we're going to pour that into our Buechner funnel. And we'll let that drain down as well. Alright, so now is a good time to catch up on our data sheet. We haven't shown this in a little bit. We have all of our starting weights for our starting materials for step 2, stilbene dibromide, 3.341 grams. Starting weight of our potassium hydroxide, 1.501. We have the volume of our ethylene glycol, which was our solvent system, 20 mils. And then the volume of water that we used to wash our crude product, which is in this Buechner funnel right here that we're getting ready to collect, was 10 milliliters. So we'll add that in. Now we're going to collect our impure product in this beaker, and then we'll get ready for our recrystallization. So let's go ahead and turn off our vacuum. Break our seal, and we'll take our Buechner funnel out. We can see that our crystals are already fairly dry, so we can go ahead and start scraping them away from our filter paper. Being very careful not to cut the filter paper with our spatula. Once we've scraped everything up as best we can, then we'll go ahead and tip it into, might be better if you come over on this side. We'll scrape it into our beaker. Okay, I think we've got most of our residue here. And this is our impure product that we're going to recrystallize in ethanol. But before we do that, we'll go ahead and get rid of our filtrate in the appropriate place, which is our waste bucket. Make sure we close that back up. And now we're ready to start our recrystallization. So we have ethanol, about 10 mils, warming on our hot plate here. We're going to use this to recrystallize our crude product. So I'm going to set this on the hot plate and pour in small amounts of ethanol and swirl the flask until it's completely dissolved. And we want to make sure that we're keeping this warm for the duration of this recrystallization. Once it starts to cool is when our crystals will start to reform. And we're going to need a little bit more than that. It doesn't seem to be going completely into solution. We want to try and do this with the minimal amount of solvent possible. That'll make it easier to get our crystals back out. We're going to let this heat on the hot plate for a couple of minutes to see if we can't get everything dissolved, and then we'll come back. Okay, our solution is fully incorporated. We have all of our impure product dissolved into our ethanol. We can see it's a pale yellow color. We're going to set it down here on the bench top, and we're going to add drop-wise 1/2 ml to 1 ml of water until our solution becomes cloudy. Now we can see as the droplets are added, right where they add, we see a burst of cloudiness. What we want is the entire solution to be cloudy. I'm going to swirl that a little bit. And then it goes back to transparent. Let's try swirling it again. We can already see crystals starting to form in the solution. That looks great. We'll stir this one last time, and then we're going to let it sit on the bench top to continue precipitating. We'll come back once it's finished, and we'll go through a suction filtration to obtain our final product. We've given it a couple of minutes to precipitate, and we've got some nice crystalline product forming in our solution. We can see it up along the sides of the beaker here. So we're going to go ahead and use a Buechner funnel to suction filter it, so that we can weigh it out and get a melting point. I've already wetted down my paper with a little bit of deionized water. I'll go ahead and turn the vacuum on. And then I'll pour it through. And we see some really nice fine white crystals. I'm going to use a little bit of DI water to rinse the beaker. Try and get as much of this product out as we possibly can. And that'll also rinse out some of the, we see a little bit of pale yellow color, and that's some of our impurities. So we'll rinse that through. We'll let air pull through this for about 5 to 10 minutes, try and get as much of that liquid through into the filtration flask, and then we'll collect our product and weigh it. So we've allowed air to pass through our pure crystalline product. We've got it on our Buechner funnel here. We're going to go ahead and scrape that product out. I'm going to close my vacuum, break my suction here, and scrape this off onto my pre-weighed watch glass. We'll look at our data sheet in just a moment, and we'll look at the data, look at the weight that we got for our pre-weighed watch glass here. So you can see we've got a fine crystalline, white crystalline solid here. Very little, if any, really don't see much of any type of hue to it at all. Most of our impurities were washed through into our filtrate. Just going to scrape the rest off of our filter paper here. Okay, set that back up here. And now we'll take it over to our balance and give it a final weigh. So our final weight is 63.298. My calculator, and then we'll get that final weight. So we went ahead and did our subtraction here. We've got our weight of the watch glass alone, subtracted out of our watch glass plus our product, gives us 0.835 grams of our final product, purified diphenylacetylene. This is it right here. We've seen it. There we go. And we went ahead and did a melting point using our capillary tubes and our melt temp, our DigiMelt. And our value that we obtained is 60 to 61 degrees Celsius. So this is our final shot of our data sheet, everything that we recorded during the course of this experiment. So you're going to use these values when you go through and find your percent yields, your theoretical yields for each step, and then the overall reaction.